3I Atlas, a mysterious interstellar visitor currently blazing through our solar system, isn't just another space rock drifting by.
There is a new report from NASA that shows that 3I Atlas might be picking up a little speed.
This object has begun non-gravitational acceleration, meaning it's speeding up using forces beyond simple gravity. While Harvard astrophysicist Avi Loeb suggests this could be evidence of alien technology, the reality might be far more disturbing. 3I Atlas has already demonstrated the most extreme orbital eccentricity ever recorded, turned an impossible shade of blue while approaching the Sun, and now it's accelerating in ways that defy our understanding of natural comets. But here's what NASA isn't telling you. If this acceleration continues, we're looking at an object that could fundamentally change how we view interstellar visitors forever. Subscribe to Space Aquarius and let's begin. Let me paint you a picture of what we're actually dealing with here. 3I Atlas isn't your typical cosmic wanderer. Right from the start, astronomers knew something was off. The object's trajectory showed an eccentricity between 6.1 and 6.2. That's astronomer speak for, this thing is moving so fast and on such a stretched out path that it's definitely not from around here. To put that in perspective, most objects in our solar system move in neat circles or gentle ovals around the Sun. 3I Atlas is traveling on what scientists call the most extreme and stretched orbit ever recorded. We're talking about a path so wildly elongated that it smashes all previous records for orbital eccentricity. This thing isn't looping around the Sun, it's just passing through at insane speed. This cosmic fingerprint confirms beyond any doubt that 3I Atlas is a true interstellar traveler, originating from somewhere far beyond our Sun. But the orbital weirdness was just the beginning. As 3I Atlas approached the Sun, it started exhibiting behaviors that shocked even seasoned astronomers. The object began brightening at twice the normal rate compared to typical comets. Most comets get brighter as they approach the Sun because solar heat vaporizes their icy surfaces, creating those spectacular tails we're used to seeing. 3I Atlas was brightening so rapidly that it suggested massive changes were happening on its surface. Then came the color change that nobody saw coming. 3I Atlas turned distinctly bluer than the Sun itself. Now, this might not sound like a big deal, but in the world of astronomy, this is absolutely bizarre. Natural comets typically appear redder as they approach the Sun, because dust particles scatter light in predictable ways. When an object appears bluer than our 5,800 degree Kelvin Sun, you're looking at something that shouldn't exist according to our current understanding of comet behavior. Harvard astrophysicist Avi Loeb has been tracking these anomalies closely, and he's compiled what he calls 9 separate anomalies that make 3I Atlas unlike anything we've ever encountered. The blue coloration is just one piece of this cosmic puzzle. The object also displayed what scientists call an anti-tail, jets of particles directed toward the Sun rather than away from it, which is the complete opposite of normal comet behavior. But here's where things get really unsettling. On October 29, 2025, as 3I Atlas reached its closest approach to the Sun, what astronomers call perihelion, something unprecedented happened. NASA's Jet Propulsion Laboratory detected clear signs of non-gravitational acceleration. Let me break this down in simple terms. When we say non-gravitational acceleration, we're talking about an object that's being pushed by forces other than gravity alone. The ALMA observatory detected that 3I Atlas had deviated by 4 arcseconds, in right ascension from where it should have been based on gravitational calculations alone. That might sound tiny, but in astronomical terms, this deviation is statistically significant and represents a real measurable force acting on the object. Avi Loeb ran the numbers using basic momentum conservation principles, and what he found should make everyone pay attention. For 3I Atlas to achieve this level of acceleration through natural outgassing, the process where a comet releases gas and dust as it heats up, the object would need to lose about 1/6 of its total mass. We're talking about 12 billion pounds of material being ejected into space. Think about that for a moment. If 3I Atlas is behaving like a natural comet, it should be surrounded by a massive cloud of gas and debris, carrying billions of pounds of material. This cloud should be easily visible to our most powerful telescopes. But here's the problem, we haven't seen it yet. This brings us to a disturbing parallel with Oumuamua, the first confirmed interstellar visitor we detected back in 2017. Oumuamua also exhibited non-gravitational acceleration, but despite deep observations by the Spitzer Space Telescope, astronomers never found any evidence of the gas or dust cloud that should accompany natural outgassing. This led to Oumuamua being classified as a dark comet, essentially a comet that doesn't show the defining characteristics of a comet. As Avi Loeb points out, calling something a dark comet is like calling a cave a dark sun. If the defining feature of a comet is its visible tail of gas and dust, then an object without these features might not be a comet at all. The timing of these observations is crucial. 3I Atlas emerged from behind the Sun in early November 2025, and astronomers immediately noticed it was significantly brighter. Dr. Chi-Cheng Zhang from the Lowell Observatory managed to capture the first images of the object using the powerful Discovery telescope, confirming that 3I Atlas is now bright enough to be seen with amateur telescopes. But here's what's really keeping astronomers up at night. The International Asteroid Warning Network has initiated a comprehensive monitoring campaign that will track 3I Atlas from November 27, 2025 through January 27, 2026. On December 19, 2025, the object will make its closest approach to Earth at a distance of 167 million miles. This will give hundreds of ground-based telescopes, plus the Hubble and Webb space telescopes, their best opportunity to study this mysterious visitor. If 3I Atlas is a natural comet that lost billions of pounds of mass during its solar encounter, we should see an enormous gas cloud surrounding it during this observation window. But if we don't see this massive debris field, we're left with some deeply unsettling possibilities. The acceleration data suggests that 3I Atlas experienced forces equivalent to 84 miles per day, squared in radial acceleration away from the Sun, plus 37 miles per day, squared in transverse acceleration. These aren't small numbers. They represent significant forces acting on an object that's already traveling at over 130,000 miles per hour. What makes this even more mysterious is the object's composition. Unlike typical comets that are primarily water ice, 3I Atlas shows a strong carbon dioxide signature and appears to have a heavily irradiated crust formed by billions of years of exposure to cosmic radiation during its journey through interstellar space. This 10 billion-year-old time capsule carries the chemical fingerprints of an alien star system, making it a unique window into the early universe. The scientific community is divided on what we're actually looking at. Some researchers maintain that 3I Atlas represents a new class of interstellar objects with properties we simply don't understand yet. The object's behavior might be explained by exotic ice compositions or unusual internal structures that we've never encountered before. But others, including Avi Loeb, suggest we need to consider more radical possibilities. A spacecraft with a propulsion system could exhibit non-gravitational acceleration without producing the massive gas clouds associated with natural outgassing. The object's blue coloration could potentially be explained by artificial lighting or hot engine emissions rather than natural processes. The implications extend far beyond academic curiosity. 3I Atlas represents only the third confirmed interstellar visitor we've ever detected, following Oumuamua in 2017 and Borisov in 2019. If these objects are more common than we thought, and if some of them exhibit artificial characteristics, we might need to fundamentally reconsider our place in the universe. NASA's response to these developments has been notably cautious. Despite having high-resolution images from the Mars Reconnaissance Orbiter's HiRISE camera taken when 3I Atlas passed close to Mars in early October, these images remain unreleased. Representative Anna Polina Luna has sent formal requests to NASA's acting administrator demanding the release of this data. But the agency has cited government shutdown procedures as the reason for the delay. This lack of transparency has frustrated the scientific community, particularly when NASA's administrator reportedly responded quickly to social media inquiries from celebrities while ignoring formal requests from Congress and researchers. The withholding of scientific data hampers our ability to plan future observations and understand what we're dealing with. As 3I Atlas continues its journey away from our Sun and back into the depths of interstellar space, we're left with more questions than answers. The object's unprecedented acceleration, combined with its other anomalous properties, challenges our fundamental understanding of how natural objects behave in space. The next few months will be critical. If the International Asteroid Warning Network's comprehensive observations reveal the massive gas cloud that should accompany natural outgassing, we'll know we're dealing with an exotic but natural phenomenon. But if 3I Atlas continues to defy our expectations, we might be forced to confront possibilities that extend far beyond conventional astronomy. 3I Atlas isn't just another space rock passing through our neighborhood. It's a cosmic mystery that could reshape our understanding of what's possible in the universe. Whether it represents advanced alien technology, a new class of natural objects, or something else entirely, one thing is certain: we're witnessing something unprecedented in the history of astronomy. The acceleration of 3I Atlas might be scarier than we think, because it forces us to confront the possibility that our universe is far stranger and more populated than we ever imagined. And that's a reality that changes everything. If this cosmic mystery has you as intrigued as it should, hit that new featured hype button and subscribe and ring the notification bell. We're tracking 3I Atlas through its closest Earth approach in December, and you won't want to miss what we discover next. Drop a comment below with your thoughts on what 3I Atlas really is, and share this video with anyone who needs to know that our universe just got a whole lot more mysterious.